Good morning, student. My name is K.P.G Sir. Today I will describe AC distribution system. Let AB is a distribution line. This is A, this is B. The voltage is feeding from A. At far end, that is at point B, there is a load I1 at a power factor of cos phi 1 lagging. In between A and B, suppose there is a load, suppose this is the point C, there is a load, current is I2 and power factor is cos phi 2 lag. As A.C.CB is a distributor line, so there is some impedance. Let the impedance of the BC sections, we can write ZBC. ZBC is equals to R1 plus JXL1, and this section AC, suppose the impedance of these sections ZAC is equals to R2 plus JXL2, where R1 is the resistance of this section BC and inductive reactance of this section BC is equals to XL1, and the resistance of these sections AC is equal to R2 and inductive reactance of this section AC is equal to XL2. Now let the voltage at the B, suppose this we can write VB. VB is the voltage at the far end, and C portion voltage we can write is VC, and the voltage across the A, suppose this is V abbreviation, according to abbreviation this is VA. Now how we can calculate the voltage at different point? We can solve by vector diagram. So at first we draw the vector diagram. Let taking voltage at the far end, taking is the reference line. Suppose this is a voltage at VB. Now we can write VC voltage, VC vector is equals to VB plus voltage drop across VC. current in this section CB is equals to I1, because current flowing from C to B is I1, and the current in AC section, that will be the vector sum of I1 and I2. So this current we can write I total, I vector is equals to I1 vector plus I2 vector. There is a current flowing to this section's AC. Now VC voltage is equals to VB voltage plus this drop. So this we can write VC is equals to VB I1 vector plus into ZBC. So we can write VB plus I1 in vector form R1 plus JXL1. So how to draw the vector diagram? As the reference line is VB, so I1 is lagging at an angle with respect to I1 is lagging with respect to VB at an angle of phi 1. We can write here phi 1 angle, phi 1 is the VB and I1. This is the symbol of angle. So phi 1 is the angle between VB and I1. So at first I1 is lagging at an angle I1, at an angle of phi 1. Now from VB there is two drop into R1. From VB we draw in parallel with I1 R1. I1 R1 which is parallel with the I1. And next drop is I1 into ISL1, that is perpendicular with this. So this drop is equals to I1 into XL1. So resultant is equals to I1 into ZBC. Now VC is equals to the resultant of this is the VC. Now this voltage is VC, we calculate here. Now I2, what is I2? I2 is the angle between VC and I2. So here we can write phi 2 angle is equals to VC and I2, angle between VC and I2. At first draw, with respect to VC, I2 is lagging at an angle phi 2. So with respect to VC, draw the here I2. So this angle is phi 2. Now, in AC portion, the current is the vector sum of I1 and I2. So, we add I equals to I1 plus I2. So, I1, I2 draw, addition of I1, I2 draw by parallelogram. We draw the parallelogram. This is I. I is the vector sum of I1 plus I2. Now, what is VA? Voltage across A is equals to VC plus this drop. So, VC vector plus current I into Z AC section. Now we can write VC section VC plus I plus R2 plus J XL2. So from VC there is two drop. One drop is called I1 or R2, that is resistive drop. So from VC portion we draw in parallel with the I. So this line is I1 I into R2, which is parallel with the I. Next drop is I into IXL2, which is perpendicular with this. Now draw the perpendicular with this. I into R2. Now perpendicular here, this line is called I into XL2. So this line is, we can write I into Z AC sections. Now A point is equals to the vector sum of VC and this drop. So this line is VA. So the sending end voltage can be calculated. Now power factor of this point is VB, angle between VB and I1. In C point the power factor is VC and I2. Now what is the power factor at A point? A point, the power factor is the angle between VA and I. So this is the VA point, this is phi A. So what is phi A? So phi A means phi A. Phi A is the angle between VA and I. So you can write VA and I the angle. So if the impedance, resistance, reactance is given, and if the last terminal voltage is given, so you can calculate, we can calculate any point in between any point of the voltage across C point and A point. So this is the AC single phase system. One point, this is a single line diagram. Actual there is a two conductor. One is positive, the one conductor is phase and another point is neutral. But for mathematical simplification, we draw this single line diagram. So next, this is the AC distribution of, this is called the radial system. This is called radial system. I hope you will understand, and if you solve any type of question, any type of problem by help of this vector diagram, without vector diagram you cannot solve this AC distribution and differential. Thank you all of you.